Welcome back to another video on the Monkey Mathematician, and today we'll be looking at powers, roots, and laws of indices. Now, our learning outcome for today's class is, today's video is to learn the basic index notation as well as base and power. Through that, we'll also learn about the square numbers and square roots, and we're also going to learn about cube numbers and cube roots. Lastly, we're going to finish it off with learning about laws of indices as well as doing some questions. So the first part of this is the index notation. So the index notation is a representation of multiple numbers, or basically an equation or something that's occurring, or an operation rather. So in this case, 3 is what we call the base. And this is the number that's being affected by what we call the power. So the power can also be called the exponent, and this is what is affecting the base, exponent. So in this case, 3 raised to the power of 2 is the same thing as 3 squared. So 3 times 3 is basically just double of 3, but you're multiplying together. So some teachers may say 3 squared, while others may say 3 raised to the power of 2. Either way, both methods are the same and both mean the same thing. 3 squared is equals to 3 times 3, which is equals to 9. So 3 squared is the square number of 3, which is 9. And so we then go on to square numbers and square roots. So a number is squared when it is multiplied by itself. So from the example that was before and the example that we see here now, 5 times 5 is equals to 25. 25 is the square number of 5 because when 5 was multiplied by itself, it gave us 25. Now, this can also be written as 5 raised to the power of 2 in this notation, 5 and a 2 at the top, and that's still the same thing as 5 times 5 equals 25. Now, the sign for square is base, which can give it as x, square. Whatever value it is, let's say they give you 7 times 7 and they tell you to write it in index notation, this will give us 7 square. And as we go deeper into this area, we can also find out that 7 times 7 is the same thing as 7 raised to the power of 1, and 7 is also the same thing as 7 raised to the power of 1. And when we times this will give us 7 into brackets, 7 raised to the power of 1 plus 1, which is the same thing as 7 square. But we'll go into that part later. So aside from that, we go on to the square root. So the square root of a number is the number multiplied to get the square number. So it's basically just the opposite of a square number. Whereas 25, when we put it in a square root, this will give us 5, which is the square root of 25. And something to note is that root 25 can also equal minus 5. So in this case, if you remember from last video, where we said that minus 5 times minus 5, due to them both having the same sign, minus times minus equals plus. So this would then equal to plus 25. But that's also the same thing as plus 5 times plus 5, which is the same thing as plus 25. So in this case, there are two answers for finding the square root of 25. In this case, it can be plus or minus 5. And plus or minus 5 is the same thing as plus or minus root 25, because root 25 is normally known as 5. But most times, questions will ask for just the positive answer, so you shouldn't need to worry, unless, especially when you enter into A levels or when you're starting the IGCSE program, they will always want you to put out the plus or minus in the answer. And one last thing to note is that there can be no square root for a negative number. For example, minus 25, the square root of minus 25. When you put it into your calculator, it will always give an error, especially a math error, because you cannot find, whenever two negative numbers are multiplied, it will always give a positive number. So minus, let's say you even put the largest number, minus 10 times minus 10, it'll just give you 100. There's no negative answer. So that's why there will never be a negative square root. Rather, that's why there will never be a square root for a negative number. And so that's how it is. So then we go on to the next part, which is the cube numbers and cube roots. So a number is cubed when multiplied by itself and then multiplied by itself again. So it's basically multiplying itself 3 times, well, 2 times when you think about it. That the first time is 5 times 5, and the second time is this answer times 5 again. So in this case, as we said, 5 times 5 times 5 is equals to 25. So this can also be written by 5 raised to the power of 3, or 5 cubed equals to 125. And the sign for square in index notation is x cubed, where cubed is going to be at the top and the base is going to be the 5 or whatever number they give you. Excuse me. So aside from that, we then go on to the cube root. So the cube root of a number is the number multiplied to get the cube number. So in this case, while we got 5 cubed equals 125 can then be interchanged into saying that the cube root of 125 will equal 5. So cube root of 125 means that the cube root of this answer was multiplied by itself 3 times, or 2 times rather, to get the base inside. So in this case, we should take note that 5 and minus 5 have different answers to their cubes, which is quite different from the square numbers and square roots. In the case that when you do minus 5 times minus 5 times minus 5, when you first do 2 parts of it, minus 5 times minus 5 is a positive 25. So plus 25 times minus 5. This will then give us, due to it being positive times negative, this will then give us a negative answer. So this will then be equal to minus 125, compared to the normal 5 times 5 times 5, which equals to 125. Also, this should be 125 here, please, because I made a mistake while typing it. So anyways, this should equal to minus 125. And one last thing to note, in the case of index notation for cube roots, the sign for square roots and the sign for cube roots, what's that? So this should be cube actually, because I've messed it up at the end. So the sign for cube roots will be equals to x raised to power 1 over 3. This shows that this number, which is the x, is being operated in a cube root. So as well as that, the sign for square roots will be equals to x raised to power 1 over 2 to show that it's being operated by a square root. So aside from that, the next ones can be seen with the square numbers. So there are different types of square numbers, and so we're meant to, well, for beginners and for the first stage, you're meant to know the first square numbers from 1 to 15. So 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16, 5 times 5 equals 25, 6 times 6 equals 36, 7 times 7 equals 49, 8 times 8 equals 64, 9 times 9 equals 81. We're getting into bigger numbers now. 10 times 10 equals 100. 11 times 11 when multiplied will give us 121. 12 times 12 will equal 144. 13 times 13 equals 169. 14 times 14 equals 196. 15 times 15 equals 25. And if you can get confused, sometimes you can possibly get confused, but most of the time you should memorize this. For something like 15 times 15, if you don't understand, you can simply just do the basic multiplication, where you do 5 times 5, which is 25. You then take 5 down and put 2 up here. 5 times 1, which is 5, add 2, that will then be 75. You then give it space, it should then be 1 times 5, which is 5 here. 1 times 1, which is 1. Then you add it all together. 5 is 5 here. 7 plus 5 is 12. Take 2 and put 1 up here. 1 plus 1 is 2, so 2. So that will give you 225. You must be able to understand how to also do basic multiplication if you don't understand how to get to the square numbers with the memorization, but you should be able to know the first 15 square numbers. Next up is cube numbers. So cube numbers, in this case, we are just meant to know from 1 to 10. But of course, as you go on to later stages, you should be able to know many more, but you can also be using your calculator during those periods. So 1 times 1 times 1, which is the same thing as 1 cubed, equals 1. For any value of 1, which is raised to the power of anything, the answer is always going to be 1. Anyways, 2 cubed is the same thing as 2 times 2 times 2, which is 4 times 2, which will equal 8. 3 cubed is the same thing as 3 times 3 times 3, which is the same thing as 9 times 3, so that will equal 27. 4 cubed is 4 times 4 times 4, that will then be equals to 16 times 4, that will then be 64. 5 cubed, 5 times 5 times 5, that will then be equals to 25 times 5, so that will then be 125. 6 cubed is 6 times 6 times 6, so that will be 36 times 6, and that will then equal to 216. 7 cubed equals to 7 times 7 times 7, so that will equal to 49 times 7, so that will be 343. 8 times 8 times 8 is 8 times 8, so 64. 64 times 8, that will then give us to 512. 9 times 9 times 9, which is 81 times 9, that will give us 729. And 10 cubed is 10 times 10 times 10, which is then equals to 1000. Surprisingly, tens are very easy to find out, because for this, you can just do 10 times 10 times 10. You can just take the numbers of zeros. Due to there being 3 zeros, you then just put them all together. So that will then equal to 1000. So that's just something to know. So after that, we then go on to the index notation and products of prime factors. So I'm using this in one of my old videos. You see how I use this to find the HCF and LCM of different numbers, but by using the index notation. But in this case, we're just looking for expressing 200 as products of its prime factors in index form. So 200, there are two ways to find this, which is the factor tree and the division method. But again, I'll be using the division method because it's much easier to use. It's much easier to use rather. So 200, we'll then put this in a tabular form. So 200, we'll then find the lowest prime number that can divide 200 without giving a remainder. So that'll be 200 divided by 2. So that'll be 100. You then do it again. 100 divided by 2. That'll then give a 50. 50 divided by 2. That'll then give a 25. 2 can no longer divide 25 without giving a remainder. So we then look for the next prime number that can divide 25 without giving a remainder. In this case, that will be 5. So that will then be 25 divided by 5. That will be 5. 5 can divide again. So that will then be 5 divided by 5. So that will then be equals to 1. So when you reach 1, that's when you stop, because you can no longer find anything to divide 1 by that is a prime number. So that will then be 2 times 2 times 2 times 5 times 5. This is going to be your answer. But you should know that they are asking it to be found in index form. This is just as a product of its prime factors. So to get it in this index form, you must take these 3. This will just be like 2 times 2 times 2. That's the same thing as a cube. So that will be 2 cubed. And then 5 times 5 is the same thing as a 5 square. So that will then be 5 square. So in index form, the product of prime factors of 200 is 2 cubed times 5 square. Then the last part is now the laws of indices. This is where things will get interesting. Now, the indices, as we saw before, is basically the x raised to power of y's that we saw before. That x is the base, y is the power / exponent, etc. So there are different laws to how these indices will work. And in this case, the first law is a raised to power of x times a raised to power of y equals to a raised to power x plus y. But let me not write this here. I'll give an example at the side. So also to note, all of these are using the same base, which is a. There are 2 different bases cannot be used to find these laws. They must be using the same base. So For example, 5 raised to power 2 times 5 raised to power 3. Due to it both having the same base, the two powers can be combined together to give a 5 raised to power 2 plus 3. That's the same thing as 5 raised to power 5. You must understand that when there's a multiplication sign between two bases that are the same, you must add the powers together. And now, number 2's on the second one is a raised to power x divided by a raised to power y is equals to a raised to power x minus y. So let's give 5 raised to power 3 divided by 5 raised to power 2. This would then be a division sign. This would then give us 5 raised to power 3 minus 2. So that would then equals to 5 raised to power 1. Number 3, a raised to power x all into brackets raised to power y is equals to a raised to power xy. For example, excuse me, 5 raised to power 3 all brackets squared. So this would then be equals to 5 raised to power 3 times 2. This is only when you can multiply, when there's a bracket that's holding it all together. So that would then equals to 5 raised to power 6. The reason why is because 5 raised to power 3 squared is the same thing as 5 raised to power 3 times 5 raised to power 3. And with the original law that said we should add, it's the same thing as 5 raised to power 3 plus 3 as 5 raised to power 6. This is an easier method though, so it's beneficial that you understand this. Number 4's own states that a raised to power 0 always equals 1. So a raised to power 0, 5 raised to power 0 equals 1. It doesn't matter. Even if there's like 216 raised to power 0 equals 1. If they put a very humongous number, like 10,564 or something, and they put this number for you, and they put raised to power 0, just know that the answer is equals to 1. Aside from that, number 5 says that a raised to power minus x equals to 1 over a raised to power x. So, for example, 5 raised to power minus 1. This minus seems to show a change in the numerator and denominator. So, the base will turn from the numerator to the denominator. So that will then equal to 1 over 5 raised to power 1. The same thing can apply, let me erase some space so I can get some space. The same thing can apply for something like 1 raised to power 5 all raised to power minus 1. Write that down there. 1 over 5 all raised to power minus 1. In this case, 5 will change from the denominator to the numerator. So in this case, they switch roles. So the answer is now going to be 5 raised to power 1 in this case. Number 6 says a raised to power 1 over 2 equals to square root of a. So just as before, in this case, when a number is raised to power of 1 over 2, so let's give 25 raised to power 1 over 2. That would then be the square root of that number. That would then equals to 5. Well, actually plus or minus 5, because there can be two answers for the square root of a number that is not negative. If the number is negative, if the number 25 is turned to minus 25, then that would be an error. So the same thing can go for something like 125 raised to power 1 over 3. The 1 over x is always used to show a root being used. So in this case, 125 raised to power 1 over 3 will then equals to cube root of 125. That's the same thing as 5. And last but not lastly, that will be question rule number 7, and that is the a raised to power x over y equals to this root of y all raised to power x. So for example, let's say we have 5 raised to power 2 over 3. It's the same thing as saying 5 raised to power 1 over 3 all raised to power 2. Because from the third law, when you have these two like this, you can then just do 5 raised to power 1 over 3 times 2. And that's the same thing as 2 over 3. Let me erase this so it's easier to see and not see like 5 over 1 over 3. So this can be 2 times 1 over 3, which is 2 over 3, which is the same thing as the third law. But in this case, 5 raised to power 1 over 3 can be changed into the cube root of 1 over 3, of 5 rather, of the base. Remember, it's the base that's always being affected. So of 5, cube root of 5, all into brackets square, because square is the one affecting it outside. So just to note, you must always start with the root and then go on to the square. You cannot put the square in first and then go on to the root. It is more ethical. Although they both produce the same answer, it is more ethical to go it that way. So lastly, we can then go on to some questions. Now, this question tells us to find the cube root of 0.729. If you put that into your calculator, or even if you continue doing work on it, you can notice that 729, the cube root of 729 is the same thing as 9. But now, it's now 729 over 1000. So remember, this cube root here. 729 over 1000 is the same thing as 0.729. So, due to this being the same thing, we can know that this cube root of 729, this can both act independently. The cube root of 729 all over the cube root of 1000. They don't have to act simultaneously, they can both act independently. This can be used in some questions where they don't allow calculator, and with IGCSE now, they are no longer allowing calculator in paper 2, so you must be able to understand how to do this without using your calculator. So here, you can change the base and make it into its numerator form, and numerator and denominator form, where it can be 729 over 1000, which is the same thing as 0.729, where you do 1, 2, 3, and decimal places here. So you can then act independently on them. The cube root of 729 is 9, and the cube root of 1000 is 10. So your answer will then equal to 0.9 when you do the decimal place. So 0.9 is for this first one. The second one is now 5 raised to the power of 4. So, excuse me. Raised to the power of 4 shows that it is going to be multiplied by itself 3 times. So it's going to be same as 5 times 5 times 5 times 5. You don't have to know if it has to be multiplied 3 times, 4 times, etc. Just put it out like this. Just know that there's going to be 4 5s that will multiply each other. So 5 times 5 is the same thing as 25. 5 times 5 is also the same thing as 25, if you put them into brackets. So 25 times 25 is then going to be equals to 625. But if you do the normal multiplication classic form, you can just do 25 times 25, etc. 125 and 50. That will give you 625 here. But the answer is still going to be the same. And lastly, 4 raised to the power of minus 2. Now, you must first always take into account everything that is shown in the index form. So 4 raised to the power minus 2. We should not start with the 2. And also, minus is independent from the 2. So, it's now going to be, if you want to break it down actually, you can also do 4 raised to the power minus 1, all into brackets 2. Because the third law says that when it is put in a raised to power down, you just have to multiply both of the powers together. So 2 times minus 1 is the same thing as minus 2. And for remembrance from the 4x a raised to the power minus x equals to 1 over a raised to the power of x. We can know that, let me also write it down, a raised to the power minus x equals to 1 over a raised to the power of x. In this case, this is minus 1, so it's now going to turn into 1 over 4 raised to the power of 1 and then squared. 1 does not affect anything, so now it's just going to be 1 over 4 squared. So that's then going to equal 1 over 16. So the answer for this last one is 1 over 16. And with that being said, we have come to the end of powers, roots, and laws of indices, where we're able to look at the powers, the index notation, how to use index notation in finding the prime factors of a composite number, as well as that we're also able to look at the laws of indices and how to use them in different situations through this work. With that being said, I hope you are able to enjoy this lesson and video. Like and subscribe and comment for more what you want to see, what you want to understand, or what you want to learn more, so I'll be able to do, so I can be able to change my ways, so I'll be able to help you guys. So with that being said, I hope you enjoy your day and goodbye.